Children, let's see next sum, children, what this one trying to say. In the given figure, PQ is equals to QR. Okay, so let's jot down PQ equals to QR. So here we say PQ is equals to QR. What next? Measure angle PQR is 56 degree. Okay, so measure angle PQR. Let me jot down with different marker. This is PQR, entire, mind you, entire angle is 56. What next? PT and QT are tangents to the circle. Fine. PT and QT are the tangents to the circle. Calculate the measures of POQ, PTQ. POQ, this one, and PTQ, this one. These are the two angles is what we need to find out. Right? Let's start. So, always go, as I stated, always go with the given stuff. What is given stuff? Given stuff is given to us. Measure angle PQR is 56 degree. So, let me write down measure angle PQR is equals to 56 degree, equation 1, that's given. Now children, what do we see? What do we see in triangle PQR? In triangle PQR, when it is being given to us that PQ is equals to QR, don't you think so it's an isosceles triangle? With an isosceles triangle, the base angles are going to be equal. The base angles are going to be equal. So, can I proceed with the base angles? We start off with, in triangle, we can easily get the values of this. In triangle PQR, segment QR congruent to segment PQ, therefore angle QRP is congruent to angle QPR, equation 2, by what? By isosceles triangle theorem. By isosceles triangle theorem. Now children, with this 56, with these two equal, can we get measure of these two? Though I have not taken x, many a times is what students take x and 56. Right, I doubt we need to take it as, we can directly move on. Now, what? Angle RQP plus angle PRQ plus angle RPQ is equals to 180. Angle sum property. Angle sum property. Angle sum property. But already we know that QRP and QPR are equal. So can we say it is RQP known to us 56 plus PRQ, RPQ, both are same. PRQ, RPQ, both are congruent. So shall I say twice angle PRQ. PRQ is 180 degree. From where did I get this? From equation 2. From equation 2. You can say, since I have taken 56 also, so from 1 and 2. What next? Now, question arises right now in students' mind, sir, you have taken twice PRQ, you could have taken twice RPQ also. Certainly I could have taken RPQ, but I have some different thinking right now going on. That's the reason I have taken twice PRQ. You could have gone for RPQ, no issues children, no issues. So, on solving twice PRQ is 180 minus 56 turns out to be 124. Only PRQ turns out to be 62. Only PRQ turns out to be 62. So if this is 62, even this is also 62. Entire angle 62. But I'm not interested in this 62. I'm very much interested in this 62. Why? I shall give you the answer. So this is my first answer, PRQ. In fact, they have not given me PRQ to be found out. So I shall give this as equation number 3. Now, what was my purpose of writing PRQ and not RPQ? Children, what type of angle PRQ will be in context to POQ? It's a inscribed angle for the central angle. And you know that central angle is twice the inscribed angle, or inscribed angle is half the central angle. We have studied all the theory. We are very much aware about the theory. So, we want to find out POQ. So POQ is nothing but our central angle. In context to POQ, what is PRQ? Inscribed angle. That's it. We are done. So if this is 62, don't you think so that this has to be? Yes, 124. This has to be 124. So we are done with the first part, POQ. So now, measure angle POQ is twice measure angle PRQ. One can say, either of the ways you can say, central angle is twice inscribed angle. Central angle is twice inscribed angle. Or you can say inscribed angle is half the central angle. Measure angle POQ. Measure angle POQ is 2 times 62. From where did I get this value? From 3. Therefore, measure angle POQ. Measure angle POQ is 124 degree. Measure angle POQ is 124 degree. My first answer. Now children, I shall give you one property. Whenever within the circle chapter, circles and tangents intersecting chords chapter, we have such figure whereby which there are 2 tangents on the similar lines. There are 2 tangents TQ and TP. So when we have this kind of figure, I'm talking about the quadrilateral POQT. I repeat, I'm talking about the quadrilateral POQT where TP and TQ are tangents. Whenever you have this kind of figure where there are 2 tangents, answer is, the technique is, sum of these 2 opposite angles are always supplementary. Sum of these 2 opposite angles are always supplementary. Sir, what makes you say that? I have an answer for that. Because since TP is tangent, TQ is tangent, each angle is going to be 90. When I say 90 means OPT, OQT are 90. So 90 plus 90, 180. In a quadrilateral, sum of measures of all angles is 360, out of which these 2 angles sum up to 180. So the remaining 2 has to sum up to 180. So that's a property you can use. Though we won't be using this particular property here, I'm just giving you can use that particular property. We won't be using it over here. So we directly write down. Also, measure angle OPT is equals to measure angle OQT is 90. OPT is equals to OQT, which is 90. You can say radius is perpendicular to tangent. Radius is perpendicular to tangent. Radius is perpendicular to tangent. With this, we say now in quadrilateral. In quadrilateral, which one? POQT. Measure angle OPT plus measure angle OQT plus measure angle POQ plus measure angle PTQ. That's what we want. PTQ is how much? 360 degree. Sum of measures of all angles in a quadrilateral is 360 degree. So we just need to write down here sum of measures of all angles in quadrilateral, or you can say angle sum property for quadrilateral. Angle sum property for quadrilateral. Next, what here? OPD is how much? 90 plus 90. POQ is how much? 124 plus measure angle PTQ is 360. So from where did I get these values? From, this is 5, this is 4. So from 4 and 5. What next? You sum up 90 plus 90, 180. 124. Or you can say 360 minus 180 is 180. 180 minus 124, answer is 56. So measure angle PTQ is 56 degree. Measure angle PTQ is 56 degree. As I stated, you could have used that particular property. Always, children, keep this in mind. Whenever you have length of tangent segments drawn from an external point, and when you take the circle, center of the circle into account, not any point on the circumference, children, no. It is only when a quadrilateral is formed by the external point forming 2 tangents and the center, not any point on the circumference, no. If such quadrilateral is there, then sum of opposite angles are always supplementary, right? So this is it.